So welcome everyone, and thank you for coming along. We are today going to be talking about, I'm going to be showing you a sort of simple processing workflow for how to take, in today's case, Environment Agency LiDAR data and process it sort of very simply in order to make it more useful for viewing, finding, looking at, exploring archaeological sites that may be showing up in the LiDAR data. My name's Ed Pevler, for those of you who haven't met me before. Hope is that the session takes about an hour, then with time at the end for Q&A. So do save up your questions for the end and feel free to type them into chat and I'll deal with them when we get towards the end and we can unmute and things at the end. So plan for the session. Quick intro to what I'm doing, the reason that this session is happening, which I'm sure lots of you already know, our Beacons of the Past project, to explain about that. Quick overview of the software that we're using, and then we'll talk about how to find, download data from the Environment Agency's website, how to merge tiles together, how to then create visualizations from them to try and extract more information, and then how to sort of view those finished visualizations with base maps. So that's the basic plan for today. And just to start off with a nice image of Maiden Castle, I think one of the most spectacular archaeological sites in the country, particularly from the point of view of LiDAR. This Maiden Castle down near Dorchester, Dorset. So just to give an introduction to me and the project that I'm working on. So I'm employed by this thing called the Beacons of the Past project, which is a 3.5-year project based at the Chilterns Conservation Board. We are predominantly National Lottery Heritage Fund funded, with additional funding from various other societies and groups such as National Trust, Children's Society, and local county and parish councils. So we're very grateful to our donors and for the funding. We are a team of 2, myself and my colleague, Dr. Wendy Morrison, the project manager. And this project has 3 real aims. We are looking at, we've got these things called our beacons, the beacon of discovery, the beacon of learning, and the beacon of protection. So what these basically break down to, we want to research, we want to share knowledge, and we want to work to protect archaeology in the Chilterns AOMB, and in particular the Iron Age archaeology of the Chilterns, so the hill forts and other elements of the prehistoric landscape of the Chilterns. But a large part of this project, as many of you know, is a LiDAR survey. So we're using LiDAR to investigate archaeology across the Chilterns, and of course the LiDAR is forming the backbone of one of our largest bits of outreach, which of course is the citizen science project to try and record archaeological features seen in the LiDAR data. Today's session, though, of course, is about going a bit beyond just the Chilterns LiDAR and looking at LiDAR from across the rest of the country. Just a quick background on LiDAR. I won't go into too much detail here, but just for those of you who haven't come across LiDAR before, or haven't sort of read much up on it. So LiDAR stands for light, distance, and ranging. It is a remote sensing technique used for creating a high resolution, high accuracy topographic model of a landscape. So all the lumps and bumps across a landscape with very, very high resolution. In those lumps and bumps, we hope we can identify and map archaeological remains that survive as extant earthworks. And we can detect these using LiDAR even when they are very slight and even when they are under tree cover. This is what makes LiDAR so powerful, is it is capable of detecting these even very slight or sort of otherwise masked archaeological earthworks. I've greatly enjoyed putting this PowerPoint together because it's meant I got to go off and look at LiDAR data from all around the country. So we had Maiden Castle on the previous slide. Here we have Chester's Fort up at Hadrian's Wall. So I think Chester's Fort is actually this one, this feature here. But hopefully, those of you who have spent a bit of time looking at LiDAR, you'll spot that we have many other fantastic little bits of Roman archaeology in the vicinity. All these little camps around there, and then the line of Hadrian's Wall running through there, and the sort of military road, the Vallum, running along the back there, and also some lovely ridge and furrow farming in the vicinity. So that's what LiDAR is. If you want to go and learn more about the basics, then just a reminder, we of course do have our free tutorials available through the LiDAR portal for the Chilterns Beacons project. So if you go to the chilternsbeacons.org website, you can then register, and there's several free tutorials on there giving you a bit of a background to what LiDAR data is, how the data is collected, how it's processed, all those kinds of things. So for the Beacons of the Past project, we've flown 1,400 kilometers squared of LiDAR over the Chilterns AONB and its vicinity. And we've flown our data at 25 centimeter resolution. So we have 16 measurements hitting the ground for every meter squared on the ground of altitude. So this allows us to detect pretty small archaeological features, probably in the vicinity of sort of 50 centimeters in width. But what we're talking about today are much larger LiDAR datasets. So this is to show you what the Environment Agency have flown to date. I'll explain a little bit more about the Environment Agency survey in a second. But to date, their latest release of LiDAR data, this is the coverage that they have of England. And our Chilterns survey is just there in red in the center. So you can see that one of the key reasons for flying our Chilterns LiDAR survey is, of course, that they haven't yet flown the Chilterns AONB. Being upland is far down the to-do list for flying. The other thing to note is, of course, that the Environment Agency LiDAR data is largely flown at 1 meter resolution, whereas our data, as I said, was flown at 25 centimeter resolution. So we can have a look at the end. We can see the level of detail difference that you get with that higher resolution that we used. So the 25 centimeter resolution survey that we flew of the Chilterns is actually, as far as we know, the largest bespoke high resolution LiDAR survey undertaken in this country for the purposes of archaeology. But we do have fantastic coverage at 1 meter resolution and 2 meter resolution across large parts of the country. Today, as I say, we're focusing on English data, but towards the end of the session, I'll briefly touch on data available for elsewhere in the world, if you are bored of looking at English data. So just to expand a bit on what the Environment Agency are doing by flying and releasing LiDAR data. So this data comes from this thing called the Environment Agency National LiDAR Programme. The Environment Agency started to fly LiDAR in England in 1998, and this was primarily for flood risk mapping. So for trying to detect where we might have problems from rivers bursting their banks. In 2015, they started to make this data open access as part of the government's sort of open data policies. And then in November 2016, they turned this probably slightly ad hoc sort of process of flying primarily flood-prone areas. They turned this into the National LiDAR Programme with the aim of getting complete coverage of England at 1 meter resolution by the end of 2021 and making that data open access. So obviously, once they started to release the data, they had many, many more calls from people saying, we'd love you to fly this bit over here, this bit over here. And they realized that this data had far more worth. I'm sure they already realized, but they knew that this data had far more worth than just the flood risk mapping. And so they've started this fantastic program to fly the whole of England. There are separate projects. So the Scottish government are flying Scotland. They've released, I guess they've probably got about 15% of Scotland flown. So still a long way to go there. And parts of Wales, you can see, are flown, I think, by the Environment Agency. I'm not sure whether there are plans to fly Wales and Northern Ireland. I'm sure there are plans, but not quite as far along as we have for England. So the one fantastic way that we can access what the Environment Agency have flown is through a thing called a WMS, a web mapping service. This is essentially a URL that you can plug into either desktop GIS or into kind of an online mapping system in order to display an image of the LiDAR data that they've flown to date. One of my favorite places to go and look at what has been flown to date is the National Library of Scotland's website, where they have their mapping website and their various different map viewers, including their side-by-side viewer. And in the side-by-side viewer, you can select the Environment Agency's LiDAR data as one of the drop-downs there. So this is the WMS of the Environment Agency LiDAR data 1-meter digital terrain model. And you can view that side by side with all the lovely historic maps that the National Library of Scotland have got on there. So that's a great way to go and just have a look and see what's been flown. And you get the data showing up as this sort of green color ramped, slightly hill shaded visualization of the data. And as you can see, there are holes, but as again, large parts of the country already covered. And that will only continue to increase. However, the way this layer displays is not particularly optimal for archaeological prospection. And that's part of the reason for today's session, because you can go and view this data through the NLS website or through the Environment Agency's website. And you can see a good amount of detail in there. However, for the purposes of sort of looking at archaeological sites, often this sort of color ramp with a bit of a hillshade doesn't work particularly well. And just to sort of illustrate that point, here's an image from that Environment Agency web mapping service versus an image that I've processed using the method I'm going to show you today to create a specialist visualization that is designed to bring out more information from that data. So those of you who are used to using the Chilterns portal, you probably will recognize this site. This is near sort of Wallingford. Beautiful bit of open field with fantastic preservation of a field system, whether it's medieval or Roman or prehistoric, we're not quite sure, but you can see how using a sort of specialist visualization we can see these features far more easily than in that WMS that the Environment Agency provide through their website. So we want to take this data, download it, process it to turn it into something that allows us to see the data with a little more ease. Just to touch on the software that we're going to be using for today's session. So the very first thing that we're going to be using is QGIS. I'm sure lots of you are familiar with this, also known as Quantum GIS. It is an open source geographic information system. So it's a fantastically powerful bit of GIS software that is completely free to download. And there's a huge, because it's open source, there's a huge amount of documentation online, tutorials on YouTube in how to use it. So a really fantastic project, brilliant bit of software. The other thing we're going to be using is this piece of software called RVT, Relief Visualization Toolbox. This was developed by a Slovenian researcher in a Slovenian university, specifically for turning digital terrain models into images that are easier to view for looking for things like archaeology. So again, a really lovely bit of open source software. I'm afraid it is only does only work on Windows, so I'm very sorry to those of you who might be on a Mac. You'll have to find a friend with a Windows PC. But you can download that from this website here. As I say, I'll be sending out the PowerPoint so you can get the links from that. And there's the instructions there for how to download and install those bits of software. So let's make a start. The very first thing you're going to want to do is to check what has been flown. You know, is the thing that I'm interested in, does it have coverage yet in the Environment Agency survey? This will obviously be developing as we go along, so through the year, hopefully by the end of 2021, we should have the whole of England covered. So what you're interested in, it should be there. But for now, we're stuck with these few gaps. So you're going to want to double check that the thing that you're interested in has been flown. And you can do this through the National Library of Scotland's web mapping, or you can go directly to the Environment Agency's web mapping to look at this. I'm just going to switch my screens now to my browser to show you what the Environment Agency's website looks like. So this is the DEFRA Data Services platform, that link that was just there on the PowerPoint slide. And the link I've sent you to will directly load up the layer that we are particularly interested in for archaeology. So on the right-hand side here, you just have to tick the WMS link, tick the LiDAR Composite DTM 1-meter 2019 link, and then tick that one where it has the red blue color bands. And as you can see, that then should load in there. And as you zoom in, you'll get detail in there. And if you want to look at the base mapping underneath, you can just turn the layer on and off to see where you are in the world. So a really useful way to start to see what's been flown and what hasn't. bear with me 2 seconds. We're just going to flick back to the PowerPoint. Worth just comment there. So there are a number of products available from the Environment Agency's LiDAR survey, including a thing called a DSM, a digital surface model, the DTM, the digital terrain model, and the raw point cloud data, so the sort of the primary data product of LiDAR survey. The DTM is the one that we are most interested in as archaeologists, because this is the sort of essentially the bare earth model, all the vegetation, all the buildings, everything that's on the surface of the landscape has been processed out to leave us with just bare earth. We're using the composite layer because this, I think, is the easiest to use. This together all the surveys that the Environment Agency have flown. If you're interested in accessing an in-survey, you can get just the results of 1 particular year's worth of surveying. But the composite's useful because it just sticks together, sort of amalgamates everything that they've flown. So you may well be able to detect sort of slight edge effects where they go from, you know, a survey that was flown in 2010 to the survey that was flown last year, because the way they've flown it, the kit that they're using, has sort of obviously been updated. But DTM composite is the easiest thing to use. So first step, check what's been flown, find your site of interest. Second step then is to download that data. And for this, we're going to need to access the Environment Agency's download portal. Again, a slightly different website. So this is, again, the link here. We'll click that, and that will take us to the DEFRA survey data download website. Slightly irritating that it's a different thing, but hey ho. So the thing you're going to need to do here, the first thing you're going to need to do is you're going to need to open the layer list to add the particular layer of interest that we want. So you can see I've clicked on little stacks of layers here to open the layer list, and the one we want is at the very top here, the LiDAR composite catalogs. So I'm going to turn on that one. We don't want 2017, we're going to hide that. We want the 2019 data, the most up-to-date, and I want the 2019 1 meter index. Now, slightly annoyingly, this doesn't load in kind of the gappy survey showing you where all the holes are. This loads in just all the tiles where even just some tiny part of that tile has been flown. This is the reason we had to double check against the kind of more detailed data view, because you may go to download a tile saying, well, they've flown this, you download it, and then it turns out they've just got the tiniest little corner has been flown, and you kind of think, well, that was a waste of my time. So this just loads in the tiles that have got some coverage, and you're going to go to where you're interested, the place that you want to look at. For this session, I'm going to go and look at a place called Chilterns on Salisbury Plain. And in particular, so you could have, I've used the search there just to zoom to the particular place I'm interested in. Now we need to choose the tiles that we want to download. So I'm going to go across to this download your data button. And then I'm going to click on this button here that says polygon. And this is going to allow me to draw around the area that I'm interested in. For this session, I want ST94 Northeast and ST94 Southeast. Worth noting that when you draw this thing, it doesn't matter kind of quite what shape you draw. It will give you the option to download any tile that this polygon that you've drawn sort of touches. So for this, it's going to give me the option to download ST94 Northeast and ST94 Southeast, not just the bits that I've coloured in. So now I've drawn my polygon. I'm going to click this button here that says Get Available Tiles. And that's going to think about it for a second, and then hopefully we'll see how my internet holds up with streaming video and trying to download LiDAR data. There we go. So it's now giving me options for things to download. Crucial thing to check here is it's actually giving me the wrong layer. It's giving me the LiDAR Composite DSM. I want the LiDAR Composite DTM. And I want the DTM 1 meter. So that's all now correct. And you can see it's giving me 2 little blue links here. So I'm just going to click on both of those and start those downloading. And hopefully that shouldn't take more than a second or two. Okay, so just to run through those steps again in the PowerPoint. So we've gone to the download portal, turned on our composite catalog index, and then we have moved to where we want to look, opened the download your data panel, used the polygon to draw around our area, clicked get available tiles, changed the settings to the correct product, and then clicked on each tile hyperlink to download them. Let's just go back to my screen. Oh, sorry, people have been having problems. Apologies if some people have been having issues. Not sure there's a great deal I can do, I'm afraid. So hopefully those tiles have now downloaded. So I'm just going to show those in the folder. So there we go, I've got 2 zipped files here. Now I'm going to move these to a folder that I've got for looking at LiDAR data. So my GIS folder, my LiDAR folder, Environment Agency. I'm going to create a new one called Chilterns. I'm going to paste those 2 zip folders in there. I'm now going to unzip these 2 folders just by right-clicking on them and clicking Extract All, or in my case, extract here. Okay, and you'll see I've got various bits and pieces that have now come out, but the 2 important files are these 2 TIFF files, the ST94 Northeast DTM and Southeast DTM TIFF file. You can see they're the really large ones. And you can now delete those zip files if you want, because you've got the raw data there. So now we're going to open QGIS, because now we want to merge those files together. So I've opened QGIS here. I've started a new project, and the first thing I want to do is I want to load in those 2 files that I've just downloaded. So I'm going to click the Data Source Manager button up here in the top left. Again, don't worry about following too closely. I'll be sending out the PowerPoint. It has all the instructions in. So I've clicked that Data Source Manager. I'm making sure I've got raster selected in the type of data. And I'm going to click the 3 little dots to open up, hopefully, thinking about it, there we go, to open up my folders. I'm going to go to the 2 I've just downloaded, select them and click Open. And then click Add. It's asking me about transforming my projection. I'm going to click Cancel, because it should just automatically update it to the correct projection for me. So there we go. I've now got my 2 tiles of data. You can see if I turn in the layers panel, we've got 2 layers of data there. And as you can see, I can't see very much in here except the stream system. I can't see any archaeology in this data. Don't worry, we're going to get to that. We're going to fix it. So my first task now is to merge these 2 panels together. The reason we're merging it is because if we process these separately, we'd end up with a great big edge effect down the middle. We'd end up with a great big sort of divide down the middle of our nice, neat images that are meant to show off archaeology. And having a big horizontal line through your data gets very confusing and annoying and in the way of all the archaeology you want to look at. So I'm going to go to the raster tools here, miscellaneous tools, and merge. And I'm going to merge these 2 files together. So input layers, I'm going to select my 2 raster layers, and then I'm going to give these to a file by clicking there. I'm going to go to Chiltern and just call it Chiltern merge. And then I'm going to click Run. And that should only take a second. Okay. So I can just get rid of now my 2 original layers. And we've now got 1 great big merged tile. Worth noting here, I wouldn't suggest, depending on how powerful your computer is, I wouldn't suggest merging more than about 4 tiles. I'm only doing 2 today to keep things nice and quick for the demonstration. I'd probably do 4 at the most, because it starts to get quite hefty, quite sort of intensive on your computer. So 2 to 4 is probably about the most I would do. And of course, if what you're interested in sits neatly on one tile, then just use one tile. That works fantastically. Inevitably though, if you're looking at your hill fort, half of it will be on the tile you're looking at, and then the other half will be disappearing off the edge. So that's why it's worth checking what you're interested in first through that WMS that I showed earlier. So now I've got my merged DTM file. I now need to process that into something that shows off the archaeology better. And this is where that second program I mentioned comes in, this program called RVT. So when you've downloaded and unzipped RVT, you just get a folder that looks like this. So currently it's RVT 2.2.1. You open that folder and it just has this application in here. You don't need to install anything. You don't need to play with any of these folders. You just have to leave them where they are and just double click on this application file. It brings up a little sort of intro panel. Just click to continue and you get the program opening like this. And it's all very simple. Where it says add files, I'm going to go in and add my file for Chiltern, my Chiltern merge file. And then I'm going to select the outputs that I'm interested in, so the different visualization types I'm interested in. For today's session, I'm going to create two. I'm going to, actually, let's go for 3. Let's go for hill shading from multiple directions, a simple local relief model, and sky view factor. The basic settings that it comes with, you can change here. So to the right, I could say how many directions I want, what the elevation I want for my sun angle for my hillshade. I think you can just leave those as they are, really. You know, when you start to get really into this, you can tweak these a bit and see what the different effects are. But the basic default settings, I think, do a pretty good job. So I'm happy with all those. I'm just going to click Start. And you can see this comes up with a little sort of progress bar. This will think about it for a minute or two, and it should start flashing once it's finished. I'm just going to go back to the PowerPoint whilst it's thinking about all that. Just going to double check chat as well, just to see how people are doing. I can't see the chat bar. Oh well. So just to flick through those instructions again. So we opened QGIS, we loaded in the file, we then moved it all into one single file. This is what I meant by edge effects. So if I'd processed those tiles, you end up with these horrible little lines in between everything. So you want to try and get rid of those because they're not nice. And then we've opened RVT. We've added our merged file. We've chosen our desired outputs and settings. Click Start, and then hopefully it should be running. Let's see how that's getting on. So you can see here's my Chiltern file where I've got my Chiltern merge TIFF files I created a second ago, and you can see that new files are starting to show up. So we've got a thing called Chiltern merge multi-hillshade. We've got 2 of those. We've got Chiltern merge SLRM, so that's the local relief model that's appeared. So we're just waiting on the sky view factor file to finish. So we should be hopefully nearly there. The chat window up, but I'm failing with my Zoom controls. Can't do it. There it is. Everyone doing all right still? Again, apologies if you had sound issues. Obviously, we're recording it, so hopefully that should have decent sound. Just as a quick note, to keep your files tidy, I might just stick all my sort of raw tiles that I downloaded into a little folder called tiles, leaving my merged tile in the kind of root, and then all my visualizations will appear beneath that. So the RVT outputs will be put into the exact same folder as the source file used to create them. Just to explain the different files created then, so there's my merged file that I created in QGIS, and these are the outputs, the multi-hillshade, local relief model, sky view factor. You'll see that there's a pair of each. So there's 2 multi-hillshades, 2 local relief models, and 2 sky view factors. And that's because one is a 32-bit file and one is an 8-bit file. It doesn't matter too much what that really means. Suffice us to say, if you want to just open them in an image viewer, then you'll probably have to use the 8-bit file, so the second one, so the RGB or the 8-bit files. Whereas if you're going to use QGIS, then you can use the 32-bit file. And the 32-bit file will look better, it will have more information in it. The 8-bit file will still look okay, just not as detailed. But if you're not using GIS to look at it, then you'll have to use the 8-bit file. Hopefully, yes, my sky view factors have now appeared as well. So now I've got my multi-hill shade, I've got my local relief model, I've got my sky view factor, and I've got a log file as well. And if you, as I said, if you wanted, you could sort of then tidy away all these extra just deep files. You could even delete them if you want. You don't really need those again because you've got your merge file as well. So back to QGIS. So we can merge file now because that's no use to us. And now we want to add in some of those visualizations that we have created. So let's open this up, and I'm going to select my multi-hill shade, my local relief model, and my sky view factor image, and add all those in. And of course, those are going to appear on top of each other. That's the sky view factor one, there's the local relief model, and there's our directional hill shade image. Your sky view factor and your local relief model image, depending on whether you're lucky or not, they may not come out looking particularly detailed to start with. You may have to play with the settings a little bit to show up better. So the way to do that is to double click on the layer, choose the symbology tab, and then what I would suggest is you're going to make sure this says stretch to min-max here under contrast enhancement. And rather than having it at min-max, I would use the cumulative count cut and just cut 1% of the ends of the data off, and then click apply, and you'll see that really kind of heightens the contrast in the image and makes things a lot clearer. And I'd suggest doing the same thing with the sky view factor. You can see that's all very, very white. We can't see a great deal there. So I'm just going to go to double click on it, the layer, go to symbology, check that it's stretched to min-max, cumulative count cut, and just cut sort of 1% off the ends of the image. Alternatively, you could use the mean plus or minus a couple of standard deviations. Might go to sort of 5 standard deviations, say a bit dark. So if you just sort of move this over to one side and sort of play with it until you're happy and you think you've got a good image that's showing you kind of enough detail in the landscape. There are those settings. And then we've got our images. So this looks obviously a lot better, I would say, than the WMS that we were looking at earlier. Let's go and just have a compare, shall we? Let's see how the visualizations compare to the web mapping service. So hopefully that should load in. Going to load. Just thinking about it. No, not going to play. Oh well, you'll just have, oh, there we go, we're there. So the area we've downloaded is sort of in here, and hopefully it's struggling a bit with, I think, streaming video and loading these things. But hopefully, as you can see, we've got an awful lot more information coming out in our specialist visualizations than we had in our just plain colored WMS. You can see these features in here, the sort of field system we've got going on here in a hill foot. But I hope you'll agree, they are an awful lot clearer in our sky view factor image, in our local relief model image. You get a fantastic view of all those field systems, and in our multi-directional hill shade. Maybe not quite so powerful in the multi-directional hill shade. Again, we can probably do a bit here just to heighten it potentially. No, not gonna. There we go. There you go. So sort of slightly heightening those colors to bring out these field systems. So just to show you what we've got here, we've got a, this is, try to remember the name of the site, I think it's Nook Camp, or Nook Castle. which is presumably an Iron Age hill fort, but has a load of Roman activity all around it. And these field systems are presumably Iron Age, with a series of Roman farmsteads. So this is a Roman farmstead just up here, or beautifully preserved because it's on Salisbury Plain, because it hasn't been built over. I think this is another Roman farmstead that survives as an earthwork. So a very, very rare survival of fantastic prehistoric and Roman remains as really clear earthworks. And just to the north, as I said, we're on Salisbury Plain, fantastic remains of practice trenches dug on Salisbury Plain by the army training, World War I, World War II, and more recently come out really, really clearly in our visualization techniques. And just to the north, I think this is all shelling. This is all practice range shelling as well. So some fantastic, really exciting, interesting archaeology showing up beautifully in the LiDAR data. So just to finish with the demonstration, so we've loaded our visualizations into QGIS. Depending on your computer, again, having only one layer turned on at once may speed up loading times. It can be a bit intensive to have all this data on at once. As I said about tweaking the symbology, have a bit of a play, but in my experience, using the stretch to min-max and either the cumulative count cut to just a percentage or two at the top end, or the standard deviation are good ways to go to try and bring out as much information as possible. You may want some base mapping to go with your data in order to sort of put it in context. So the way that I would suggest doing that is using XYZ tiles. Various services online have put together these things called XYZ tiles that allow you to load in base mapping into things like QGIS. So again, use the PowerPoint when I email it out to do this, but I've put here the names and links for several useful base mapping layers. So for example, the OpenStreetMap base mapping layer, Google Satellite or Google Hybrid. So to load these, you just find XYZ tiles in the browser pane, right click it, click New Connection, and under Name, put OpenStreetMap, and under the link, put the URL there. And then you can just double click these layers over here to sort of load them in to your map. And it may give you little warnings about transformations, but it shouldn't be a problem. So you can see here we've now got nice aerial imagery to go underneath our LiDAR data. So you can have a look at that. Otherwise, I think that's all I have to say in terms of teaching how to do it. As I say, it's hopefully very, very simple and straightforward. As I mentioned, this obviously is English data that we're looking at here through the EA LiDAR portal, but many, many other countries have made their LiDAR data open source. So for example, the whole of Belgium is online, for example. Large parts of Slovenia are online. So across Europe, you'll find an awful lot of data available. A fantastic collation of data sets can be found at this website here. An archaeologist called Joost Herbich, who works with LiDAR data a lot, very active on Twitter, he's put together on his blog a list of freely accessible LiDAR data and digital terrain models. So you can see here he's got his list of all different countries and lots of hyperlinks to take you to the pages where you can go and have a look at this. So from France, Germany, Italy, etc. So loads and loads of places around the world, Canada, America, Haiti, Australia, New Zealand, etc. And he gives you a few sort of details about each particular data set as well. So things like the resolution and any sort of difficulties or tips for using that particular data set. So that's really useful if you've got interests outside of England. And the process will be much the same. Find a DTM file, download it, and then process it using RVT and load it. Obviously, I've not told you anything about how to interpret LiDAR data today, but just to plug again our Beacons of the Past website, you just have to go and register, and then you can look at our tutorials there on how to interpret LiDAR data. Although be aware that these were written with sort of lowland southern England in mind in terms of the archaeology that we're spotting in the LiDAR data. If you're looking at Germany or Saudi Arabia, then of course you're going to have very, very different archaeology showing up and looking very different in the LiDAR data. Obviously, I'm not going to be cataloguing your finds in other LiDAR surveys. For those of you who don't know, in the Beacons of the Past project on the website, we've got our LiDAR data up online and the facility on there for you to digitize and sort of circle archaeological sites that you can see on there. And let us know so that we can catalogue the archaeology across the Chilterns. Obviously, we don't have the scope to catalogue archaeology across the rest of the country or even beyond, but I am keen to see your images. Feel free to share those with me, post them on the forums on the Chilterns Beacons website, or tweet them at me. Always great fun to see different bits of archaeology in LiDAR. And I think that's pretty much all I have to say for now.